So this is an extension of the first part. This observation, this is about what? The unique way to represent a number in the binary system. And here, the same. This is a unique way to represent a number in the decimal system. Okay? Okay. Interesting, right? Now, for the same thing, we have another view, a different view. This time, let's look at a different view. Let me use a different color. Let's say orange. You can, rather than divide 1 minus x, you can divide the other part so that I keep 1 minus x on one side, but then I keep the inverse of the other part in the other side. So I will have 1 plus x, 1 plus x squared, 1 plus x4, 1 plus x8, 1 plus x16, and so on and so forth on this side. Now this is rather strange, but let's see. Okay, let's see. So we can still expand it a little bit, right? So we have this one. So what is 1 over 1 plus x? I know what is 1 over 1 minus x. 1 over 1 minus x is 1 plus x squared plus x cubed plus x4, etc., etc. How about 1 over 1 plus x? What is it? 1 over 1 plus x, it is equal to? Well, similar. You can plug minus x into the 1 over 1 minus x formula. You get the same result. So it will be alternating something like 1 minus x plus x squared minus x cubed plus x4 minus x5 and so on and so forth. Is that okay? Now the second term will be 1 minus x squared plus x to the power 4 minus x to the power 6 plus x to the power 8 minus blah 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 and so on and so forth. And then the third one, 1 minus x to the power 4 plus x to the power 8 minus x to the power 16 plus something and so on and so forth, and then you have infinite number of terms together. Okay? Now, question. So again, we are interested in finding what is the coefficient of x to the power r. Okay. Forget about the left-hand side first. Left-hand side is to check us. But what is the meaning of the coefficient of x to the power r here? So if you expand this, the coefficient of xr, it will have, okay, you can think of this as there are some positive terms, and then you want to minus some negative terms, right? Does that make sense? You have some positive terms that you come out. Let's look at x. What is the coefficient of x to the power 4? Okay, to get x to the power 4, how do you get? I may be choosing 1, 1, 4. Is that okay? So in that case, I get a minus 1 for this one. I can be choosing 4, 1, 1. Is that okay? And then 1, 1, 4, I get minus. And then, but then for this 4, 1, 1, I will get a plus. Is that okay? And then what else? What else can I get x to the power 4? I will have this one, x squared, 1. Then I will also get x to the power 4, right? Let me see. Anything else? Do I have anything else? Yeah, there should be one. I think there should be one more. To get x to the power 4, how do I get? 4, 1, let's do it again. Let's double check. 1, 2, 3, 4, 5, 6. Yes, 2, 4, 6, 8. Yes, how do I? Then the next one is, and then I also have this one. I also have 1, 4, 1. Am I correct? 1, 4, 1. And I also got a positive 1. Right? Okay. So sometimes I will have terms that is positive, and sometimes I will have terms that is negative. Okay. Now how okay, and then actually each term that we count, because the coefficient here of the original part, for each part, the coefficient of each term is equal to 1, right? So whenever we get a positive, then it is positive 1 plus 1. Whenever we get a negative, it is negative 1, right? So this is one observation. The second observation is, how do we determine we are having plus 1 or minus 1? Okay, so let me list out. Okay. How about this one? Let us take a look of the coefficient of x to the power 4 as an example. Okay. So how many cases are there? So we can have 1, 1, x4. Then we get x to the power 4, right? And then in that case, 1, 1, x to the power 4. And then we get, for this one, we get negative 1. Is that okay? And then what else? We can have 1, x to the power 4, 1. Is that okay? 1, x to the power 4, 1. And then for this one, we get positive 1. Is that okay? And what else? We can have x2, 1. And then for this one, x2, 1, we get negative, right? And then what else? We can have x4, 1, 1. And how about this one? This one we get plus 1. Is that okay? Okay. But still, it doesn't tell what is going on. How do we determine plus 1 or minus 1? Let's investigate a little bit more deeply. So remember, each choice here corresponds to a certain way to partition the number 4. Okay? So 1, 1, x4 corresponds to the partition of 4 into just the single number 4. Does that make sense? And then how about this 1, x4, 1? It corresponds to what? It corresponds to I'm picking 2 items from the second expression. Each second expression, each item is like 2. So it corresponds to 2 plus 2. Does that make sense to you? This is I'm picking 1 or 1 1 2 1 3 1 4 1. This is I'm picking 1 2 2 2 3 2 4 2. Is that okay? So if I'm choosing 1 x4 1, this is I'm picking 0 1s, 2 2s, and then 0 4s. Is that okay? How about x2 1? What does that mean? I'm picking 2 1s and 1 2. Is that okay? So it corresponds to 1 plus 1 plus 2. Is that okay? And then the last one, x4 1 1. Then I'm picking 4 1s. Is that okay? Okay. Okay. So what's so special about this? All partitions here all of them use what? Use 2 powers. as the component. So we are talking about how to partition 4 into a sum of 2 powers. So they can be 1, they can be 2, they can be 4, they can be 8. So each part has to be a 2 power. Okay? And what else? Let's test your observation. If I have 4, then I will correspond to a count of -1. 2 plus 2, for this case, I'm going to count it as +1. Is that okay? And then 1 plus 1 plus 2, I should be counting it as -1. And then 1 plus 1 plus 1 plus 1, I'm counting it as +1. So when should I be counting +1 and when should I be counting as -1? Any idea? Any idea? Okay, or we just focus on this one. Sometimes minus, sometimes plus, right? If I'm picking no ones, I count it as plus. 1 1 minus. 2 ones, again plus. 3 ones minus. So how do I know when should I have a plus or when should I have a minus? I would have a minus if the power is an odd number. Is that okay? And then plus even. Similarly for this one, I have a minus when I'm picking 2 odd number of times. I have plus when I'm picking 2 even number of times. Is that okay? Similarly for this one, I'm having minus when I'm picking 4 odd number of times, and then plus when picking 4 even number of times. So this should be related to odd even, right? If it has odd number of parts, just 1 part or 3 parts, then it would be -1. Does that make sense? If it has even number of parts, then it would be +1. Is that okay? Make sense, right? We think of it as odd plus odd is even. Okay, that's good because -1 times -1, it becomes +1. So it gets cancelled. Okay, so in the end, whether it is -1 or +1, it just talk about how many parts are there in the partition. If the number of parts is odd, then it is -1. Number of parts is even, then it is +1. Okay, so what does the coefficient mean? So positive is even parts. Right? And then, how do I get a -1? Each -1 corresponds to a particular partition that has odd number of parts. Is that okay? And then this corresponds to what? So the coefficient of x to the power r is what? It is the number of ways to partition R into 2 powers, sum of 2 powers. The number of ways. Such that we differentiate the ways into 2 different groups. One is the number of partitions that has even number of parts, and the number of partitions that has odd number of parts. And it turns out that the coefficient is the difference of these 2. Is that okay? Okay. So in this case, there are 2 ways to partition 4 into even number of parts, and there are 2 ways to partition 4 into odd number of parts. So the difference here is going to be 0. So the coefficient of x to the power 4 is 0. Is that okay? 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 Good. And what does this tell us? This is equal to 1 minus x. What does this tell us? It tells us that whenever r is greater than or equal to 2, the number of ways to partition r into even number of parts must be the same as the number of ways to partition r into odd number of parts, where each part is a 2 power. Does that sound interesting? Let's take a look. Okay, let's take a look. This time, let's choose another number. Let's choose 6. Let's choose 6. Okay, so this time, let's choose r is equal to 6. Okay, so we have, so let's list out what are the different ways to partition r. into 2 powers, okay? And then count the odd parts and count the even parts. So each number has to be at 2 power. So you may have 4 plus 2. So this is one way, am I correct? And then you can have 4 plus 1 plus 1, okay? Is that okay? And then you cannot have 4 anymore. These are the only cases that involves 4. So let's try 2. So you can have 2 plus 2 plus 2. This is one way, right? Or you can have 2 plus 2 plus 1 plus 1. This is another way. Is that okay? And then you can have 2 plus 2. I know. 2 plus 2 is gone. So you must have 2 plus 1 plus 1 plus 1 plus 1. So this is 2. All the 2's are listed, right? So the only case left is 1 plus 1 plus 1 plus 1 plus 1 plus 1. Okay? Did I miss anything? So these should be all the cases where we can partition 6 into 2 powers. Do I miss anything? Okay. Let's look at, so this is odd. This is even number of parts. So you get a plus 1 for this one. 3 parts, you get a minus for this one. Is that okay? 1, 2, 3. This is 3 parts, you get a minus. 1, 2, 3, 4. 4 parts, you get a plus for this one. Is that okay? And then 2, 1, 1, 1, 1, 1, 1. So this has 5 parts, so you get a minus for this one. And 1, 1, 1, 1, 1. So you get 6 parts, and then it is even number. And then you will see that, oh, there are exactly 3 ways with even number of parts, and then 3 ways with odd number of parts. Is that okay? So it holds whenever r is greater than or equal to 2. But what happens when r is equal to 1? When r is equal to 1, there is only one way. 1. And it is odd. So you get a minus for that. And how about r is equal to 0? 0, you have just one way, 0. You cannot choose any number, right? So you choose nothing, nothing. So in that case, nothing is an even number, right? You have even number of parts. So it is corresponding to a plus 1. Does that make sense? Yeah, so I hope you like it. So this is something which is non-trivial. So this is to interpret our original formula in a different way. This time is 1 divided by this 1 plus x squared, 1 plus x to the power 4. And then for this one, we are looking at what? We are looking at partitions into 2 powers. You can have repeated thing. Because in this formula, you have x squared, x cubed, x4. You can choose 1 multiple times. You can choose 2 multiple times. You can choose 4 multiple times. And you get a result. But on the other hand, for this one, this is an alternative way to view this thing. And then this time, this corresponds to partition of number into 2 powers. But then this time, distinct. You can choose 1 time at most, 2 1 time at most, 4 1 time at most, and so on and so forth. And then different thing will give us different view of a combinatorial result. So I hope you like it. Okay, so how about this? So this is the end of the discussion on generating function. So this is just an introduction, because later we are going to talk about this recurrence relation. We will see generating function again, because generating function is a useful tool, especially to solve recurrence relation. So let's take a break of 10 minutes, and then we come back and then continue the discussion on the new topic here. Okay, thanks.